Here I have three vectors. I have vector A, vector B, vector C. They have a magnitude. A has a magnitude of 40 newtons, B has a magnitude of 50 newtons, and C has a magnitude of 45 newtons. Their direction is given by the direction that the arrow is going. So A is going off to the right, B is going to the down and to the left, C is going to the right and down. I want to add these three vectors together. Now, one of the things that is useful is to try to draw vectors to some form of scale. So what I've done here, and I'm going to grab a ruler or something to measure with. Here, each one of these marks is 1 centimeter. So what I've done here is I have a vector of 40 newtons, and I drew it about 4 centimeters. So each centimeter is representing 10 newtons. So that one's drawn about 40, or 4 centimeters, so that represents 40 newtons. Now we'll check to make sure I drew this one right. I'll bring this up to here. I'll bring this up to here. And down, and I draw that about 50 newtons, or 5 centimeters. We'll check C out. Bring it down. We'll move this back into place. And you can see that's about 4.5 centimeters, or 45 newtons. So I've drawn everything to scale. Now I want to add these three vectors together. Now it makes no difference when you add vectors together whether I add A first and then B and then C, or I want to do A, C, and B, or I could do B, C, and A. And I'm going to prove this to you that you get exactly the same answer. So I'm going to start with vector A. I'm going to move it into place. I can locate it anywhere I want. So I drop it in, and then I'm going to grab vector B. Now the thing to note when you add vectors, that this part right here has to be head to tail of the other vector. You cannot do head head, you cannot do tail tail. That has to be head from the first one, tail for the second one. Now we'll move C into place. I drop C into place, and again, notice how I do head to tail. Head from this vector, tail to this vector. My resultant vector is going to be from the tail of this one to the head of this one. Drop that into place. And you note here, tail, tail on the resultant, head, head on the resultant up here. So I'll color this. I'll make that, let's see, a good color. I think I'm good. I'll make it orange, and I'll make it a little thicker too while we're at it. I'll give it some properties, and let's make it thicker. So that's my resultant vector. Now what we could do, if we want to know what the magnitude is, we could grab this, drop it down, rotate it into place. Get as parallel, close as we can to parallel. It's pretty close. And now we could measure what the length of that is. And you'd notice that's a little bit over 5. So that means the magnitude of that is slightly over 50 newtons. So I've added a 40 newton vector, a 50 newton vector, and a 45 newton vector, and my resultant is 50 newtons, or 51, or something like that. So now, if we wanted to find the direction of this, all we'd have to do then is get a protractor, and we could actually, I think, spin this thing around, move this into place, and we could actually determine what the direction of this would be, and we could say this vector has a magnitude of approximately 50 to 51 newtons, and it's roughly negative 40 to 41 degrees relative to the positive x-axis. So again, that's a vector, it has magnitude, and it has direction. Alright, move these out of the way. Now, I want to prove to you it doesn't matter which orientation I do these in, whether I want to do B plus A or C plus, excuse me, so whether I want to do B plus A plus C, or I want to do C plus B plus A, or keep it as A plus B plus C, I'll get the same thing. So I'm going to move my resultant out of the way, and I'm going to prove to you it makes no difference. So here I did A plus B plus C. I'm going to move these back, put it back into where they were. Now I'm going to do b plus c plus a. So I drop my b into first. I bring my c in second. And notice how I do head to tail again. I bring a into here. Again, head tail right here. So this is b plus c plus a. Look what happens when I drop this vector in. You get exactly the same resultant. So it makes no difference. Let's try this time. Let's do c plus b plus a. If I move my b back in, move my a back in, I'll move my c back in. So we're going to do c plus b plus a. I drop my c in, I bring my b in. Again, notice head to tail here. I bring my a over to here. Again, head to tail. That's critical. What I've noticed where most students will make a mistake, they'll do something like this, and that is incorrect. You cannot do that. It has to be head to tail. And again, when I drop my resultant in, look at this, exactly the same resultant. Again, I'm not a little off just because I'm not lining these up perfectly. Okay, so it makes no difference as far as when adding vectors which one you do first.